Okay, so we begin with example 1. Okay, for chapter 6, okay, DC machine. Okay, so for example 1, okay, the given example is compound DC generator. Okay, so a 240 volt compound DC generator has the following parameters. Okay, remember for compound we have 3 resistance. Okay, amateur, series field and shunt field resistance. Okay, and then this is our VT lah, terminal line. Okay, so this is compound DC generator, and then given at full load the line current is 10 ampere, and then the motor run at 950 rpm. So yang ni adalah N lah. Okay, so the first one, okay, the first question, draw the circuit diagram and the power flow of the generator. Actually you can refer to the slide. Okay, so for DC compound generator, okay, so yang ni adalah EG lah. This one is EG. This one is RE. So yang ni combination RE and EG kita panggil amateur circuit. Okay, because of this is compound, so dia ada RF2 in series. This is RF2, and then RF1 in parallel. So yang ni adalah amateur circuit, field circuit, RF1 and RF2. Okay, the parallel, actually the parallel dengan RE, and then series, RF2 is in series with RE, and then we have our terminal line lah, VT. Okay, positive, negative, VT. So this is IL. So this is IF. Okay, and then the current flow here is IE. So remember for generator, okay, the current is flow from amateur circuit, and then dia akan supply to the line. Okay, so if we can determine to determine IF, okay, for this junction, at this junction we know IA equals to IF plus IL. Okay, for generator, okay, IA equals to IF plus IL. So to determine IF, we know that VT divided by RF1. So IF equals to VT divided by RF1. Okay, and then you can rearrange lah this question. Okay, but for question A, it just ask to draw the circuit diagram and then the power flow of the generator. So remember for generator, the P out is VT IL. Okay, and then this is P in. Okay, and then this is PM. PM is always close to the amateur side. Okay, before PM must be P mu lah. Okay, dia akan ada losses. Okay, otherwise PM dia akan ada dia akan sama dengan PM. So that's why lah, okay, P in, P mu, which is our mechanical losses, and then PM. So and then we have 3 type of losses because of we have 3 resistors. Okay, PRE, PRF2, and then PRF1. Okay, also you can call PCA, PCF2, PCF1. Okay, samalah dia punya term yang berbeza, tapi the power is similar. Okay, so we know that this one because of IA squared RE, this one is IA squared RF2, this one is IF RF1. Okay, you have to look what is the current that flow through RF1, RF2 and RE, and then multiply by the current squared of the current lah. Okay, to determine power. Okay, so to determine P in, P out plus all the losses akan dapat P in. Okay, so this one is number question for E. So next one for B. Okay, to determine B is generated EMF ataupun EG lah. Okay, EG remember equals to, okay, VT plus IA RE plus RF1. Okay, so VT we know 240 volt. Okay, based on question, so we need to find IA. So for this case, okay, given the line current IL, So IL is located over here. This is IL. Okay, so from this equation we already know the IL, which is 10 ampere. So and then from this circuit also we can determine IF, okay, which is IF VT divided by RF1. Okay, 240 divided by RF1 is 250. Okay, so dia mention sini shunt field resistance. Okay, shunt refer to parallel. So the resistance that parallel with amateur circuit adalah RF1. So this one is 250. And then the series field resistance, okay, the field resistance that series with amateur circuit is RF2. So this one is 0.05. And then lastly RA given is 0.15. So you can determine IF by VT divided by RF1. So IF is 0.96. Okay, and then you want to determine IA. So IA equals to IF plus IL. Okay, we know the IF 0.96 and then IA is 10. Okay, so the IA is equals to 10.96. So plus 10.96 multiplied by RE is 0.15 plus RF1 is this is RF2 bukan RF1. Okay, because of the current that flow through RF2 is IE. Okay, based on this circuit. Okay, yang ni actually based on this is KVL. Okay, this is equation is KVL. Okay, negative positive, negative EG plus IA RA plus IA RF2 plus VT equals to 0, and then we rearrange, dia akan dapat this one lah. Okay, so EG equals to RF2 is 0.05. Okay, so you can calculate. So the EG is 242.92. Okay, so the answer is logic lah, because of this is generator. So you need to supply on the output 240 volt. Okay, so on the generator side, okay, the voltage must be higher compared to on the load side lah. So yang ni kita consider load. Okay, yang ni adalah generator side. So you need to supply 240 volt. So for sure on the generator side, okay, the voltage must be higher, and then the power also must be higher compared to load. Okay, so itu adalah EG. Okay, so the next question, okay, we want to determine the input power in terms of horsepower. Okay, okay, find the input power in HP. Alright, so we know that the P in for generator is, okay, VTIL, okay, which is our output power, plus with total P losses. Okay, so VT is 240 multiplied by IL is 10. Okay, plus P losses we have 3P, PCA plus PCF1 plus PCF2. Okay, okay, so you can calculate this one. This is, okay, IE squared RA plus IF squared RF1 plus IA squared RF2. So remember on the power on, okay, series field resistance, the current flow is IE. So this one is multiplied by IA squared. So you calculate the answer is, okay, 2.654 kilowatt. Okay, so how to convert from kilowatt to horsepower? Okay, so remember the cycle, horsepower, and then this is kilowatt. Okay, to convert from horsepower to kilowatt is by multiply 246. Okay, why 246? Because of 1 horsepower is equals to 746 watt. Okay, so yang ni actually 7.745 point something. So kita just ni bundarkan jadi 746 watt. Okay, and then from kilowatt to horsepower, so we have to divide by 746 lah. So kalau yang ni darab, yang ni mesti bahagi. Okay, so to convert P in, okay, in term of horsepower. So P in, okay, from kilowatt to horsepower divide by 246. So if you can divide, the answer is 3.55 horsepower. Okay, so that is the number C, find the input power. And then for D, find the overall efficiency of the generator given that the rotational losses is 600 watt. Okay, so you need to determine the overall efficiency, which is P out over P in multiplied by 100%. So we know that the P out is equals to VTIL. So this one is VT multiplied by IL equals to 240 multiplied by 10, so 2400. And then P in, okay, given in this question, okay, the P mu adalah 600 watt. So P in new, so actually kita dah dapat P in, but for this question the P mu is not given. Okay, it's given on the next question. P in new equals to P in yang kita cari tadi plus dengan P mu. Okay, so akan dapat 3.254 kilowatt. Okay, so by inserting this question, efficiency equals to, okay, to 400 P out divided by 3.254 kilowatt. This is 2.4 kilowatt. Okay, multiply by 100%. So you can get the answer is 73.75%. Okay, and then the last question is generator output torque. So we know that T out equals to 60 or P over 2 pi n. So because of the question asked for T out, so ini adalah P out lah. Okay, P out adalah VTIL. Okay, VTIL. So 60 multiplied by 2400. Okay, 2 pi multiplied by n. N adalah 950 rpm. Okay, so the answer is 24.12 Newton meter. So the unit for torque is Newton meter. Okay, so I continue the second example on the next video.